In this video, I am going to explain about what is Fourier's law. Fourier's law is a basic relation for heat transfer by conduction. That is, heat flux is proportional to temperature gradient. For example, if you take a flat plate with the thickness of delta x, one side surface temperature of this flat plate is T1, other side surface temperature of this flat plate is T2. If the temperature T1 is greater than T2, then heat flow occurs from higher temperature to lower temperature. That is, heat flow occurs in this direction. That means heat flow occurs from left side to right side direction. That heat flow occurs perpendicular to the surface area of the flat plate. The shaded part is the surface area of the flat plate, which is perpendicular to the heat flow. Here delta T is the temperature difference between T1 and T2. If we plot a graph between temperature and distance at steady state and one-dimensional heat flow, we get a linear relationship between temperature and distance. Here Q is the heat transfer rate, which is defined as heat transferred per unit time. From the experimental results, it was observed that heat transfer rate Q depends on temperature difference, thickness of the flat plate, surface area. For suppose delta T, which is the driving force for heat transfer, increases, heat transfer rate also increases. Delta X, which is the thickness of the flat plate, increases, heat transfer rate decreases. Surface area increases, heat transfer rate also increases due to the availability of more surface area. These relations we can write. Q is directly proportional to temperature difference. Q is inversely proportional to thickness of the flat plate. Q is directly proportional to surface area. Combining the above three relations, we can express as heat flux is proportional to temperature gradient, which is Fourier's law. Here heat flux is defined as heat transfer rate per unit area. Temperature gradient is change in the temperature with respect to distance. We can express this relation with including the proportionality constant. Q by A is equal to minus K into delta T by delta X. Here K is the proportionality constant, which is thermal conductivity, which is the property of the material. Here we included the negative sign. Why? Because here heat transfer occurs in the decreasing temperature direction. To make the heat transfer rate positive, here we included the negative sign. This equation for an element of differential thickness, we can write the above equation in the form of differential equation. Q by A is equal to minus K into dt by dx. Finally, this is one-dimensional form of Fourier's law equation. The units of parameters of the equation are: first, SI units of heat transfer rate is joules per second or watts. Another one is heat flux, which is Q by A, which has the units watts per meter square. Temperature has the units kelvins. Surface area has the units meter square. Distance has the units meters. Thermal conductivity has the units watts per meters kelvins. This is all about Fourier's law. Thank you.